In this class, we will discuss calorimetry and also look at a typical calorimeter. In the previous sessions, we have seen the principle of mixtures, method of mixtures, in which the heat that is received by one body is the heat that is given out by another body when they are in contact and there is a difference of temperature between them. So the principle of mixture of, the principle of calorimetry or the method of mixtures can also be said as heat received is equal to heat given. Now, in the experiment to find out the amount of heat energy given by a burning P, I had said that one of the problems in conducting that experiment is that the heat is going to be lost by the water to the surroundings, the water inside the test tube. And if we control for that, then we will be able to get a value for the calorific content or the heat content of the P closer to its experimental value. This can be done by avoiding loss of heat from the water, which mainly happens in three ways. They are conduction, convection, and radiation. And in order to prevent the heat loss in these methods, in these ways, we use a device called as a calorimeter. A calorimeter is a fairly low-tech device. I have drawn the diagram and I'll explain the various parts. I will also show you a calorimeter that I have over here in the class. And it's basically made up of 3 or 4 parts. So one part is the wooden container, the one that you see at the lowest point, sort of cuboidal wooden container, which is hollow inside. Now we use wood because wood is a poor conductor of electricity, poor conductor of heat, and will not allow the heat from inside to escape. That container also has the lid which slides on to the top and therefore prevents heat loss from the upper surface. Inside the container is a layer of wire gauze or wool which is wound around in the inside. Again, you use wire gauze or wool because it traps air in between, and once the air has reached the temperature of whatever there is inside, then the air which is trapped inside does not escape and therefore the heat does not go out. Air is also a poor conductor of heat. Within this wire gauze or wool layer goes a copper container. Okay, so that is where there is a slight break because the wooden container is a poor conductor of heat. The wire gauze is also a poor conductor of heat, but the copper container is not a poor conductor of heat. In fact, copper is a good conductor of heat. So there is something slightly different going on. We will come to that later when we discuss the actual calorimetry experiment. Meanwhile, you can think about it. Why use copper? And then inside the copper container, you have a stirrer. Okay, again, the stirrer also serves a purpose. Although I will explain it later, it helps to even out the temperature inside the container when you pour a fluid inside it. I will say how. And then inside the container goes the thermometer, which is put in from the top. So this is the construction. The whole thing kind of compacts itself into the box. And what the box actually looks like, I will show you in a moment. So a standard laboratory calorimeter looks something like this. Okay, and I'll take it apart and show you what it's actually made up of. So thermometer goes right on top like this. I've just put a wad of paper over here because otherwise the stand is a bit loose. So I take off the thermometer. Okay, and then here is the sliding lid that I was talking about, the wooden lid. So this wooden lid comes off. Okay, and inside this is the stirrer that is used for stirring the liquid. So when the lid is closed, you can stir the liquid inside it by pushing this stirrer up and down. And then you have the copper container. It can take approximately 100 ml of some fluid inside it. Mostly we use water. I'll explain that in the when I discuss the experiment. And then the woolen layer that goes inside it, and the wooden box at the bottom. So this is how kind of standard um, laboratory calorimeter looks like. It's a very sort of simple device, and in the following class I'll explain how this device is used for conducting calorimetry based experiments. Thank you.